Welcome to lesson 109. Today we are going to be able to find equivalent fractions. But before we do that, let's practice one of our irregular shapes that we learned yesterday in lesson 108b. So remember that to find the perimeter of a shape, we always add up all the sides. Now we notice that in this shape we're missing two of our sides. So first we need to label those sides before we can find our perimeter. So if we look at our up and down sides, the whole up and down is 5. So if this part is 2, that leaves this part of the up and down to be 3. Then if we want to find our other sideways missing side, we're going to look all the way across is 6 here. Across here is 3, which leaves 3 for this side. Now we can add up all our sides. 6 plus 5 is 11. Plus 3 is 14, plus 3 is 17, plus 3 is 20, plus 2 is 22. So we've now found that our perimeter is 22 feet. Now to find the area of our shape, the very first thing we must do is we must cut our irregular shape into two regular rectangles. We can either cut up and down or sideways. I'm going to cut up and down. So that means that I have one small jutting rectangle to the right and one long rectangle on the left. Now I need to decide which lines I'm supposed to use to find my area. I know that I have to use two connecting lines. So for my top shape, right here, I can either use the 3 and the 2 or the 6. I know that this 6 goes all the way across, but my line stops in the middle, so I can't use 6. That leaves the 3 and the 2. 3 times 2 is 6, which means that the area of this rectangle is 6 feet squared. To find the area of my other rectangle, I find my two connecting sides, and in this case it can either be 3 times 3 or 3 times 5. Now this 3 only goes to here, so I know I can't use this 3, so now I'll use my 3 times 5 is 15. When I add these together, I find that my area is 21 feet squared. Now today, we're going to be finding equivalent fractions. Now if you notice the pictures below, equal portions of each circle have been shaded. We can see that different fractions have been used to name the shaded portions. Here we have 1/2, 2/4, 3/6, 4/8, and 5/10. Now even though they have different numbers, they all name the same exact amount. The only thing that's different is the numbers that were used. All of these are equal, and all of these are equal. So different fractions that have the same amount with different numbers are called equivalent fractions. Now, let's think about how we multiply anything by 1. When we multiply something by 1, we end up with the same number that we started with. 37 times 1 is 37, 17 times 1 is 17, 23 times 1 is 23, and so on to infinity. Now it's the same exact thing with fractions. To find a fraction equal to 1, we simply make the numerator and the denominator the same. You can use 2 over 2, 5 over 5, 33 over 33, etc., etc. So when we multiply a number or a fraction by 1, we're going to get an equivalent fraction, which will make adding and subtracting fractions with different denominators possible. So if we look at the fraction 3/5, if we multiply it by 1, or 4 over 4, we end up with the fraction 12 over 20. And if we look at the pictures, we can see that 3/5 is actually exactly the same as 12 over 20. And we know that because what we did was we multiplied it by 1 using a fraction 4 over 4. Same thing with 2/3. If we multiply 2/3 times 1, and in this case we're multiplying it by 3 over 3, we end up with 6/9 because 2 times 3 is 6 and 3 times 3 is 9. 2/3 and 6/9 are the same fraction with just different numbers. So if we want to draw a picture to show that fractions are equivalent, the easiest way, in my opinion, is to use rectangles. So if we show 1/3 in a rectangle, it looks like this. If we show 2/6 in a rectangle, it looks like this. And we can see that these are equivalent fractions just using different numbers. 1/4 and 5/20 are also equivalent fractions. If we cut a rectangle into fourths and shade in one of them, we can see that it's the same as 5/20 because they are equivalent fractions. So let's practice finding some equivalent fractions. If we start with the fraction 2/3, we get to decide what we want to multiply it by to make an equivalent fraction. Let's say that I want to multiply it by 5. Now to make it an equivalent fraction, I must put a 5 in the top, wonky 5, and a 5 in the bottom. Because remember, this section must be equal to 1. Now 2 times 5 is 10, and 3 times 5 is 15. That means that 2/3 and 10/15 are the same fraction. They are equivalent. Now we have the fraction 4/9. Let's say that I want to find an equivalent fraction, and I want to use 3/3. 4 times 3 is 12, and 9 times 3 is 27. So 4/9 and 12/27 are equivalent fractions because I multiplied them by a fraction equal to 1, 3/3. Here's another fraction, 5/8. If I want to find an equivalent fraction, I can multiply it by any fraction equal to 1. I'll just multiply it by 2/2 this time. 5 times 2 is 10, and 8 times 2 is 16. Therefore, 5/8 and 10/16 are equivalent fractions. I can also do this with 2/7. Let's say I want to multiply it by a fraction with 4 in the top, so I put 4 in the bottom. 2 times 4 is 8, and 7 times 4 is 28, which means that 2/7 and 8/28 are equivalent fractions. Now I have 6/7. Let's say I want to multiply this one by 7. I have to put a 7 in the top, which means I have to put a 7 in the bottom, because now I have a fraction equal to 1. 6 times 7 is 42, and 7 times 7 is 49, and I now have 6/7 equals 42/49 are equivalent fractions. Now we have 7/8. If I take 7/8 and I multiply it by 4/4, I'll end up with 28/32. This means that 7/8 is the same as 28/32. Now, in your math book, you might come across a problem like this. Find 4 fractions equal to 1/3. We're going to multiply them by the smallest fractions equal to 1. So we'll multiply them by 2/2, 3/3, 4/4, and 5/5. 1 times 2 is 2. 3 times 2 is 6. So 1/3 is the same as 2/6. 1 times 3 is 3. 3 times 3 is 9. So 1/3 is the same as 3/9. 1 times 4 is 4. 3 times 4 is 12. So 1/3 is the same as 4/12. And 1 times 5 is 5. And 3 times 5 is 15. That means 1/3 is the same as 5/15. That also means that 5/15 is the same as 2/6. They're all equivalent fractions. All of these are equivalent fractions because all I did was multiply them by numbers that are equal to 1. Remember, when you multiply by numbers equal to 1, you get an equivalent fraction. Different numbers, same amount. One more practice. We have the fraction 2/7, and we're going to multiply them by each of these numbers equal to 1. So for the first one, we'll do 2/7 times 2/2. 2 times 2 is 4. 7 times 2 is 14. Therefore, These are equivalent fractions. 2/7 times 3 over 3 is 6 over 21, another equivalent fraction. 2/7 times 4 over 4 is 8 over 28, another equivalent fraction. And 2/7 times 5 over 5 is 10 over 35, which again is an equivalent fraction. Now remember, all of these fractions that we just found are all equal. They're just different numbers to show the same amount. It's like taking a pizza and cutting them into smaller and smaller pieces. They're the same amount with different numbers. And that is lesson 109.